We are going to be working on 3D today. So 3D is really focusing on the basics of graph, and that's really focusing on the transformation of a parabola. So just in the real world, when we're talking about a parabola or a quadratic, we're really focusing on laser pointer, this right here. It's a natural curve where we see this in the tunnel, we see it when we are shooting a basketball, it goes up to a point. This is the turning point, and then it goes straight back down. This point here, the turning point, we can also say there's an axis of symmetry down here. So what is that x value? Likewise, in the tunnel, the top point, this is our maximum value, and we've got a axis of symmetry going straight down. So um, this here just is going through everything that I've just gone through is that we've got two things we can think about. One is a minimum point and one is a maximum point. Likewise, we've got an axis of symmetry going straight down the middle. So let's look at this as an example. The basic quadratic relationship is just y equals x squared. So if x is -2, -2 squared will be 4. If x is -1, -1 squared will be 1. X is 0, 0 times 0 is 0. And it'll continue. So what we can see here is it's going to end up, before I get a graph out, it's going to end up in this shape here. So it's always going to be a minimum here. So it's a minimum when our coefficient of the x squared is a positive. If we look at that, we can see it's starting at 0, that's our turning point, and it's going up on the same amount, the same slope on each side. Let's talk about a couple of examples. So we've just done x squared. Let's now move on to x equals 4x squared. So this is getting us to understand the word dilation. So what happens with the dilation? It's focusing on the coefficient of the x squared. So when it's greater than 1, it will become narrower. So it means the gradient is going to become a lot steeper. So we can see that when we've got a 4 in front. So 4x squared. When x is 0, y is 0. When x is 1, 1 squared is 1. 1 times 4 is 4. So instantly it's going up a lot quicker. When x is 2, 2 squared is 4. 4 times 4 is 16. So already it's all the way up here. So we can see it's a lot steeper. On the other side is when a coefficient is less than 1. So I've made it 1/4 just so it's easier to visualize. So that means if x is 1, 1 squared is 1, 1 times a quarter is 0.25, 2 squared is 4, a quarter of 4 is 1. So straight away we can see that relationship right here. And it clearly shows us that it's taking a lot longer to rise. So making a dilation is knowing it's really focusing on how narrow or how wide your graph is. When we're talking about reflection, and this helps us determine if it's a min or if it's a max, and that's the two key things we need to know. So if it's just y equals x squared, we know it's going to be a minimum. If it's got a negative coefficient, I use the term maximum. Okay, so if we know that we've got y equals x squared, we're going to look at what happens when we've got y equals x minus 2 squared. So this is referring to the horizontal translation. So if we look at the basic form of y equals x minus h bracket squared, what's happening inside this bracket is going to be that horizontal translation. So let's just experiment with this table first. If I just put -2 in, -2 take away 2 is -4, squared 16. -1, -1 take away 2 is -3. -3 squared is 9. 0 take away 2 is -2 squared is 4. 1 take away 2 is -1. -1 squared is 1. 2 take away 2 is 0. 0 squared is 0. And 3 take away 2 is 1. 1 squared is 1. So instantly we can see right here that our turning point has moved 2 spaces. 2 spaces to the right. So we've gone from here, we've moved over 2. The way I like to think about it, I look at inside the brackets. How do I make that 0? X must be 2, must be positive 2, which means I'm moving 2 spaces in the positive direction. That's how I like to think about it, but it's up to you on how you interpret it. Let's look at something slightly different. This is just going to be the same. It's x plus 2 this time. So when x is -2, -2 plus 2 is going to be 0. I'm just going to put in those points now. Saves me reading through. So this here is showing that our turning point has changed when x is -2, y is 2. If you don't want to just do a table of values, you can look at this part here and go, how do I make that 0? X must be -2, which means I'm moving 2 places in the negative direction. If we look at vertical translation, and vertical means up and down, we're referring to the h, which is outside the squared part that we looked at that as previously. So that means if I have x squared plus 2, I'm going to start off with just filling in the table first. So -2 squared is 4, 4 plus 2 is 6. -1 squared is 1, 1 plus 2 is 3. 0 squared is 0, plus 2 is 2. And then it's going to start going back up through the same pattern, 3, 6, and 11. So here is the middle point. So the only thing that's happened is because of the plus 2, it's moving our growth up to 2. So whenever we think about a number on the outside, that h value, that is it moving up or is it moving down? So likewise, if I've got -1, I could fill in the table and see that when x is -1, y is 0. Another way is just being able to see it's -1 and move down to this point of -1. So when we're sketching and putting both horizontal and vertical translation together, we need to think about the first thing. So first, I'm just going to sketch the basic quadratic. The next part is I'm going to identify the vertical and horizontal translation. So the horizontal shift is looking at this part right here, and that tells me x minus 3. How do I make that 0? I make that 0 by x being the vertical is the number on the outside, which is -4, so it's shifting down by 4. So we've got horizontal shift right by 3, vertical shift down by 4. The next part is I'm going to write a new coordinate of my turning point. So that means my x value is the horizontal, so the 3. The 3. The vertical shift down will be the 4, but it's negative. It's in the negatives area. So it'll be 3, -4. Now again, out the front here, it's a positive, which means it has to be a minimum. Yeah, the last and final step is we need to sketch. So using this information, we are going to be able to sketch. So the first thing you do is you put down your turning point. Ideally, you will know your x-intercepts, but right now I'm just focusing on the transformation using the turning point. Okay, the next part that we can do is we can work out the y value. So I'm just going to pen, and we can also work out the x-intercepts. So to work out the x-intercepts, we are going to need to make y 0. So up here, I will just make 0 is equal to x minus 3 squared take away 4. We'll get x by itself. So that means I put 4 to the other side. 4 is equal to x minus 3 squared. I get rid of the square, so I square root. But remember, when I square root the 4, it'll become a positive and a negative 2. So positive and a negative 2 is equal to x minus 3. And finally, I plus 3. So x is going to be equal to plus or minus 2 plus 3. That gives me two answers. If x is positive, or so if the 2 is positive, will be 2 plus 3 equals 5. If if the 2 is negative, it will be negative 2 plus 3 equals 1. Straight away we can see if I put that down here. So 5, and I put down a 1. We can see that's the halfway point between both of those. I'm drawing up the graph a bit inaccurate on here. So that should be a 5, that should be a 1, and it's right in the center of both of them. The final part that we need is going to be the y-intercept. So the y-intercept, we just make x equals 0. So y is equal to 0 take away 3 squared, take away 4. 0 take away 3 is negative 3. Squared is 9. So 9 take away 4 equals 5. So that means I've got an intercept all the way up here. 5. Just remember to label them 0, 5. This one will be x is 5, y is 0, and this one will be x is 1, y is 0. So we do need to make sure we label everything. I'll just do one more. Sketch the graph y equals x squared and use transformation to sketch y equals x plus 5 in brackets squared minus 2. So the first thing, I'm just going to put down my basic form. I'm going to identify the vertical and the horizontal translation. So the first thing I need to look at is the horizontal. I look at the brackets. It says x plus 5. How do I make that 0? X must be negative 5. So that means it's shifting to the left by 5. And the vertical shift is the number on the outside, which is negative 2, which means it's going down by 2. If I look at writing it as a coordinate, because it's going both in the negative directions, they will both be negative. So that means I've got, oops, being eraser, that I've got negative 5, negative 2. The next step, I need to identify if it's a minimum or maximum. Well, the number on the outside here is positive, so which means it has to be a minimum. I'll use that information now to be able to graph. So the first thing I'm going to do is label my turning point, which is negative 5 and negative 2. Next part, I know it's the minimum, so I'm going to have two x-intercepts, and I'm going to also have a y-intercept. The next thing is finding the intercepts. So for x-intercepts, I'm going to make y equals 0. I'll add 2 to both sides. I'll square root the 2. So remember, the square root of 2 will give me a positive, and a minus square root 2 is equal to x plus 5. And finally, I will take 5 from both sides, and that will give me plus or minus square root 2 take away 5. Okay, so the only thing that you're going to find with this now is that with having a search, we keep it in the same format. It'll give us a rough estimate of what number we are looking for. So I know if when I'm grouping mine, it's going to approximately be in this area. Negative, I'll just put square root 2 take away 5. It's approximately negative 3.5. I'm just going to write when x is square root 2 take away 5, y is 0. And then on the other side, negative square root 2 take away 5 is approximately negative 6.4. But again, my coordinate points, my x-intercept, I'm writing it as a surd and I'm making sure that I'm labeling it. I would highly encourage you to keep it in the form. Likewise, if I'm looking for my y-intercept, the first thing that I would be doing is making x 0. So if x is 0, I'm left with y is equal to 0 plus 5 is 5 squared take away 2. 5 squared is 25, and 25 take away 2 equals 23. I don't have space up here on my graph I put, but the y-intercept would be 23, and I would expect that was labeled